Hi, I'm Jeff Hajek, the owner and founder of Relaction. This video is part of my lean training system. It was originally released as a DVD a long time ago, but times have changed and the look of some of these LTS videos is now a bit dated. The content is still spot on though, so rather than just discontinue the line, I am posting the majority of each of the 36 videos here, with the remainder available at Relaction Videos. That's our video service where you can download a wealth of supporting content and watch subscriber-only videos. I recommend subscribing and hitting the notification button if you want to make sure you don't miss any new content. I would also really appreciate if you would hit the like button if this video is helpful and you want to see more content similar to it. The like button helps us get found on YouTube, but it also lets us figure out where you want us to put our future effort. Now enjoy the free version of this video.
Welcome to Relaction Continuous Improvement Standard Work Overview Presentation. I'm Jeff Hajek, the founder of Relaction and the author of What Do You Mean I Gotta Be Lean? A good place to start is to talk about what you're going to learn. First of all, we'll define what standard work actually is. Second, we'll talk about why it is so important to a lean operation. We'll cover the components of standard work. And finally, we'll discuss some of the things you have to have in place before you attempt to put standard work into your organization. Let's begin by talking a little bit about common sense. If you're going to make an omelet, I'm pretty sure you'd crack the eggs before you drop them into the frying pan. You probably only serve up one meal at a time. And in all likelihood, there's only one person doing the cooking. So it's pretty clear that there's a lot of common sense that goes into cooking. And one of the ways that we record that common sense is in recipes. And the recipe does for the cooking process a lot of the same things that standard work does in a production environment. You wouldn't go and cook a whole week's worth of meals all at one time. You'd only cook for the meal your family was about to eat. And you wouldn't just randomly go throwing ingredients into the mix. You'd add them in the specified quantities. And it's not just the amounts that are specified. The order in which you add the ingredients is also clearly defined. So let's take all that common sense and combine it into one clear definition of what standard work is. It is a defined sequence of operations assigned to a single operator and balanced to the takt time. Now that's a nice definition, but it's always easier to understand something when you can see it. So let's take a look at this fictional U-shaped cell in a production area. Imagine it has two operators working in it. Obviously, each of them would need something to work on. And if there was an automatic machine in the cell, it would have to be loaded up also. As I mentioned earlier in the definition, standard work requires that each operator has their own precisely defined sequence of operations. And even with great standard work, it can be very difficult to work out the timing between two operators. You'll often see pieces of transitional whip at locations where work is handed off from one operator to another. In addition to the flow of people through the cell, standard work also defines how materials move. For an operation to truly have standard work, and not just some form of standardization, it has to have three basic components. The first of these components is takt time. The term takt is German in origin, and it means either the rhythm of music or the baton that an orchestra conductor uses. And that's really what it is in manufacturing also. It's the rhythm of production. It's the pace at which you are required to produce to meet customer demand. And it would be very hard to keep a consistent pace if the amount of materials you were working on fluctuated widely. But if you standardize the amount of work in process, you can make things run very, very smoothly. And that precise amount of work is called standard WIP, or standard work in process. The last of the components is sequence of operations. Every worker in the cell must have their own precisely defined order of tasks that they must accomplish. So those are the three components of standard work. When the concepts are listed out in this manner, they might seem a bit new to you.
I hope you are getting something valuable out of this video. If you want to get more out of this program, we recommend watching it on Relaction Videos. You'll be able to watch the entire video, mostly ad-free, and view subscriber-only programs. You'll also have access to a load of continuous improvement downloads.
But the truth is, there's actually a lot of common sense behind these components. Think about how the owner of a burger stand would operate. He's not going to keep producing burgers as fast as he can. He's going to try to match his pace of production to the flow of customers coming in the door. The concept of standard work in process is also fairly obvious to people. Anyone who routinely does their own laundry understands this. You can have a load in the washing machine, a load in the dryer, and one load that you're working on. The standard work in process is set so that there's one for each automatic machine plus one for the individual doing the work. You. Having a standardized sequence of operations is also fairly intuitive for people. Think of a surgeon or a pilot. They both have very specific procedures that they follow step by step in the same order every time. We understand that if they deviate, the chance of an error or a problem or just inefficiency goes up. Now, if a standardized sequence is the way to go when lives are on the line, why wouldn't we also do it in a production environment? We're now going to dive into each of these components in a bit more detail, and we'll start with takt time. Takt time is really a fairly easy concept. It's basically how long you have to produce each unit. As you start implementing more advanced tools into your production environment, takt time gets a little bit more complicated, but the basic principle is always the same. There's a set pace that you need to work to match your customer's demand. If you exceed that, you overproduce. If you don't go fast enough, your customers don't get what they're asking for. Like I said, it's a pretty simple concept, and there's not much to the calculation. It's simply working time available divided by your customer demand. So let's look at an example. Let's say you have 450 minutes available and 50 units to produce. Where do these numbers come from? Well, the 450 is basically a full shift minus all the breaks, meetings, startup time, cleanup time, and that sort of thing that takes away from actual production time. And the 50 is the expected demand during that period. So, with just a little bit of math, you now know that you have 9 minutes to produce each item for your customer. You can also make the math even easier by using a takt time calculator. As of the recording date of this DVD, Valaction offers one for free on its website at www.valaction.com. It's just a handy little tool to keep you from forgetting anything when you're doing this calculation. Taken by itself, people have an easy time understanding what takt time is. But when you add cycle time to the mix, some people get confused. To keep it straight, just remember that takt time is an equation, so you need a calculator to figure it out. If you've got a stopwatch in your hand, you're actually talking about cycle time, how long something takes to do. The confusion between the two is understandable because there is a close relationship. If you take the total cycle time of an operation and divide it by the takt time, you'll get the number of operators that are required to do the process. That equation, though, assumes that you have perfect efficiency and that the line is evenly balanced. You'll have to adjust the results based on the conditions of your operation, or you'll always be short-staffed. The other thing to consider is that when the calculation comes up as a fraction, you'll have to round up. Unless you've arranged to share a resource with another work area, a half person does not exist. If the number says 6.2 people, it's really 7, or again, you'll be short-staffed. The second component of standard work is standard work in process. Fitting all the tasks you have to do into a single takt is hard enough in the best of conditions. It gets even more difficult when the quantities you're working on are constantly changing. So how do you determine what the proper quantity for standard work in process is? Obviously, you are going to need something to work on. And if you have a partner, they will need something to work on also. And because coordinating two people in a work cell can be challenging, there is a good likelihood you'll see an additional piece of standard work in process at the transition line. You'll also see some standard work in process in automated machines. In this example, Station 3 in this work cell is automatic. Each time the operator approaches it, he will have a fresh piece of work from Station 2. He takes the finished work from Machine 3, installs a new piece, and goes on to Station 4. Machine 3 will continue to work on that piece while the operator is advancing through the rest of the cell, and when he returns on the next cycle, the machine will have completed the work. So this simple example shows all three of the basic ways that you calculate standard work in process. One per person, one per automatic machine, and one per handoff if needed. Now keep in mind that this is a very simple example, and these are some of the most basic ways to calculate standard WIP. In some situations, you will need to add additional work in process to your work cell. Some examples of these conditions are when you have a time-based process like glue drying or paint curing, or when you have a monument. And a monument is basically a big machine that works in batches. In that situation, you'll need additional work in process to manage the transition to the monument. As a side note, this is often called a curtain process. Essentially, it's like a magician. You pass the materials through the curtain, some magic happens, and you get a batch back completed.
As part of the Lean training system this video comes from, we offer a variety of Lean Lego training packages. These include our Lean Lego flow simulation, mistake proofing or poka-yoke Lean Lego exercise, and our visual controls and 5S Lean Lego exercise. We've also got an office flow simulation for those not implementing continuous improvement on the shop floor. Click the links in the description below or click on cards that pop up on this video to learn more. We'll also add links at the end.
The third and final component of standard work is sequence of operations. I don't really need to explain what a sequence of operations is, but let's talk in detail about what you get from having that precise sequence of operations defined in standard work. First of all, when you know where an operator is going to be at any point in time, you can design the layout of the cell to match the location of the operator. That means shorter walking distances to get the tools and parts they need, and in work areas with multiple people, it prevents two people from trying to be in the same space at the same time. The second benefit, and a huge one, is the ability to track progress by knowing the timing of each step in your sequence. What this means is you know precisely where you should be at any given point of time during the takt. If you fall behind, you can identify that very quickly and call for help right away. If you're not following the same sequence every single time, you'll never know if you're on track or not. The next reason, and also a big one, is that quality comes from repeating the same process over and over and over. Variation breeds defects. By doing the same sequence of operation each and every time, quality improves in an operation. This last reason for defining a sequence of operations, getting help, plays a much bigger role as you get more sophisticated in your standard work. As you pull waste out of your production processes and develop more and more effective standard work, what you'll find is that the margin for error goes down. You'll need to be able to pull an andon cord and get help immediately. By putting the supportable tasks at the end of the sequence, when a person comes to help, they'll actually have something to do. If you don't sequence it properly, a person will come over to help you and just be standing around. So that sums up the last of the three components. But as for the big picture, the question still remains, where does standard work fit into the scheme of things? Well, standard work plays a big role in the very heart of the production cycle. It takes the inputs from the suppliers, and this can be products or information, and turns it into something that a customer wants. Now you may recognize this as a SIPOC diagram, and this is really just an assessment tool that lets you see how the value chain is linked from the supplier to the customer. And standard work is a very specialized form of process, so it fits right into the middle of that SIPOC diagram. So now we've spent a lot of time talking about what standard work is, we should probably make sure we clarify what standard work is not. Standard work is closely related to and often confused with both work instructions and standards. Think of it this way. Standard work is really about defining what the work is, when to do it, and who is supposed to be doing it. Work instructions contain a much greater level of detail about how specifically to do the process. They may be called something slightly different, such as SOP or process manual, but they all have a common theme. They contain very specific information about how to do a process. They'll have torque settings, the specific part that's needed, or precise information about the methodology. Work instructions are presented at a much greater level of detail than standard work, so as a result they don't show the big picture that can help you improve flow in your operation. And finally you have standards. Now these are the specific requirements that must be delivered by the standard work and work instructions. They include things like regulations, laws, quality standards, specifications, or even technical standards or contractual obligations that you have to deliver on. So while these three different things are related, Keep in mind that standard work is different from both work instructions and standards. So let's switch gears a bit and talk about where standard work fits into the scheme of things. Many of you may recognize this image of the lean house. The most well-known version of this lean house comes from the Toyota production system, and it has been adapted by many other organizations. You'll notice that in this picture and in many others, standard work is in the foundation of the house. That's because it is so critical to developing a strong infrastructure. While the lean house shows where the concept of standard work fits into the big picture of lean, there is also the question of how standard work for specific processes fit into your operation. And that is best shown on the value stream map. Each of the process boxes on this diagram should be backed by standard work in real life. The value stream map shows how all these processes fit together to deliver value to the customer. From looking at this diagram, it becomes very apparent where you need to focus your improvement efforts, and in general, that means working on the standard work. Okay, so that's what standard work is. Now let's talk about why it's a good idea to have it in place in your organization. Think back to when we were talking about cooking at the beginning of this presentation. We use standard work for the same reason that we use recipes. Standard work provides consistent output. And it's not just about one person getting the same results each time they do a process. It's about everybody who does the process getting the same results. And in the same way that a recipe makes meal planning easier, solid standard work makes production planning less complicated. If you know how long things take to produce, it's much easier to determine your capacity. Another thing that a recipe does for you is helps you manage your shopping list. Because you know what goes into your dishes, you know what to buy. The same holds true for standard work. Because your standard work and process is well defined, managing your materials becomes much more simple. But there's another, even bigger reason to use standard work in your organization. There are many different inputs that go into a production process. And standard work has the role of synchronizing all those different inputs to get a consistent output. But all the reasons to use standard work don't stop there. That's why standard work is such a core part of lean. Not only is the list of benefits extensive, it's also broad. It impacts a lot of different areas of the organization. Let's take a closer look at some of these additional benefits. Standard work promotes the sharing of best practices. Initially, this occurs when a process is first documented. It is surprising how often things are done different ways by different people. When you write it down, everybody can see what each other is doing, and then that process is combined into one way that takes the best pieces of everybody's process. But that continues to happen as people make refinements. Every time they improve something, they document it, and that makes sure that everybody continues to know the best current practice. Another thing that standard work does is it places a close scrutiny on how people and machines interact. One of the forms we'll talk about later, the standard work combination sheet, shows visually how people and machines work together. And speaking of working together, standard work goes a long way towards improving the relationship between day and night shifts. Often, the two different groups of people do things their own way. Creating a standard work document helps them work together to optimize the layout of the area in a way that works for both teams. Standard work can also help improve job satisfaction. One of the big benefits of having a standardized process is that people can move in and out of it more easily. This enables cross-training and job rotation, so people don't feel bored being in the same job day after day. They can move around and have a bit more variety in their work. There's also an aha moment that comes when people realize that standard work is a contract that works both ways. There's an obligation to meet the standard work in terms of the pace of production, but leaders also have an obligation not to ask people to try to produce faster than standard work says. When demand goes up, leaders have to provide the proper resources. They can't just expect people to work faster. Standard work also exposes problems, and this benefits both the employee and the company. The employee benefits because the things that are causing problems are also things that frustrate them. And the company, of course, benefits because the problems are costly. When solutions are put in place, expenses go down. As we'll talk about a little bit later, standard work should be posted right in the work area. And because people are encouraged to make constant changes to their standard work as they come up with better methods, they soon take ownership of the process. And when they get that sense of ownership, they start having pride in their work. And that pride serves to make people more satisfied in their job, as well as make them more likely to take action when there's a problem. And the final benefit in this long list is that standard work provides a basis for the PDCA cycle. It provides that foundation for improvement. Taiichi Ohno, the father of modern lean, once famously said, "Where there is no standard, there can be no Kaizen." Basically, he means if you don't have a stable platform upon which to build your improvement, nothing that you do will stick. It's not a big stretch to see how all of those benefits we just talked about will impact your bottom line. Many organizations measure themselves on specific groups of KPIs, and these often fall into the categories quality, delivery, cost, safety, and morale, or QDCSM. And of course, all of these indicators, all these KPI groupings that you'll be looking at, influence your profit. They fall through to the bottom line. So the better you get in each of these areas, the more profitable the company is going to be. Now, after talking about all the benefits I just mentioned, it shouldn't be much of a stretch to see how standard work will impact each of these areas. And that's one of the reasons why standard work is so popular, why it's such an instrumental part of most lean operations. It's because it's one tool that has such a broad impact and can bring about so many gains in an organization.
Get more out of our Lean Training System videos with our Continuous Improvement Companion. It's closing in on 1,000 pages of great content. It is currently available as a download with a subscription to Vlaction Videos and as a license through our store. You can also get a free version of it by signing up for our newsletter. Click the links in the description below or click on the cards that pop up on this video to learn more. We'll also add links at the end.
Now, as great and effective as standard work is, it's not perfect in all situations. There are a few things that have to be in place to get the most out of your standard work. Now, the first thing to look for is a process that's highly repetitive. Job shops are difficult to put true standard work in place because you just don't get the consistency from unit to unit to unit. If each order or each product is different, you're not going to be able to get a standard process. That's not to say don't put standardization of the things that you can in place, but it won't truly be standard work. This lack of repetition is also one of the biggest barriers to putting standard work in place in an office environment. Most office workers either do project work or they're at the whim of the customers. Again, that's not to say don't do standardization, but true standard work with a takt time, sequence of operations, and standard WIP is just not easy to do in situations where there's not a repetitive flow of work. The next prerequisite is that the process must be observable. You have to be able to watch the process to actually record it in the first place, but also think about what standard work is intended to do. It's really a tool that lets you compare the plan to the actual performance of the work. If you can't see the work being done, it's very difficult to make that comparison. So what is work that is not observable? Well, the writing process for one. If you're talking about somebody thinking, it's very difficult to see how they go through a thought process. And there's some computer work that's also very difficult to follow. Basic data entry you can see. Something like computer programming might be much more difficult. The next prerequisite, stability, is something of a chicken or the egg argument. Standard work provides stability, but it's very difficult to put in place without some semblance of consistency in the operation. You have to take out the wild swings and variation to be able to get effective standard work started. But once it's put in place, it will act to reduce even more variation in your process. The next must-have is known demand. Think back to the takt time calculation. You have to know the demand to be able to figure out how much time you have to build each product. And, of course, takt time is one of the components of standard work. So without knowing demand, you can't have standard work. This might seem like a no-brainer to include this as one of the prerequisites, but you'd be surprised how often people do not have an accurate understanding of their demand. The first word that comes out of their mouth when I ask what demand is about, and there's no about button on your calculator. You need to know exactly what your demand is in order to set up effective standard work that can satisfy your customers. The next prerequisite is that the process must be people-based. Standard work is not the best tool to manage large automated systems. Its best application is in tracking the flow of a person through a process. And finally, a linear process is best suited for standard work. When there are a lot of branches in the process flow, or a lot of variations in the product, it's very difficult to implement effective standard work. It can, however, be used with some success if there's a product with just a few different options, or if there's some variation between different models that go down the same assembly process. But if there's a lot of variation and a lot of different branches, there are other forms of standardization that will work better. This is another prerequisite that often keeps standard work from being effectively implemented in an office environment. Because many administrative processes are very reliant upon the responses of customers, it can be a challenge to standardize a process in a steady, linear flow.
This video comes from Velaction's Lean training system, which takes a module-based approach to learning about continuous improvement. Modules include a PowerPoint presentation and student guides for every video, plus there are many exercises and quizzes as well. There's also a whole host of supporting content in the form of terms in our Continuous Improvement Companion and downloadable articles. Our modules are currently available in our store and as downloads at Velaction Videos. Click the links in the description below or click on the cards that pop up on this video to learn more. We'll also add links at the end.
So now, assuming you have all of your prerequisites met and you've gone about putting your basic processes in place, it's time to document your standard work. And that's done using three main forms. The first form is a standard worksheet. This provides an overhead view of the work and shows the flow of the individuals and the materials. It also depicts the location of standard work in process. The second form is a time observation sheet. This form is used to time the process and develop the standards for each of the steps in your sequence of operations. The last form is a standard work combination sheet. It is used to show the tasks on a visual timeline. One of its key features is that it can show the relationship between people and machines. These three forms and many others are currently available free to registered users at www.velaction.com. Let's go over each of these forms in more detail, starting with the standard worksheet. This form is intended to be very visual and show at a glance the flow of people and materials through a work cell. If you've watched any of my other DVDs, you may notice at this point I start to sound like a broken record. I always stress filling out the header data on any form that you do. It is surprising how often people jump right to the meat of a form and leave off all the identifying information. When you go back and look at this form in the future, it can be very difficult to identify exactly what it is you're looking at without the proper header information completed. The meat of this form is the depiction of flow, and its power lies in its simplicity. When you look at this, it's very easy to tell exactly where the person should be going. This is equally useful for a manager who's trying to observe a process, or for a person who's rotating into a new job and wants a quick refresher. It doesn't take a lot of time or a lot of deep thought to understand exactly where the person should be going. Of note, this standard worksheet does not show the flow of materials because they are following the same path as the person. If the material path is different from the person's path, you may see an additional line depicting how the standard work in process should move. I'd also like to give a tip here. When doing handwritten standard worksheets, it can be a big time saver to photocopy a picture of the layout and then just draw the work on top of that. That way you won't have to recreate the entire drawing every time you make a change. The standard worksheet also shows standard work in process. Now, just a couple things to note about where you actually draw it. Generally, it will be shown at the station where the work is first pulled from a bin. So in this case, Station 1 is a service counter and the operator does not have any material in front of them at that point. So that's why I've shown the standard WIP depicted at Station 2. I also recommend that you do not show every single component as standard WIP. Choose a part that best depicts the flow of the product through the work cell and use that for your standard WIP. Understand that you'll be adding additional components to that, but showing just the main assembly keeps your standard worksheet clean and easy to read. And finally, you will also see safety checks and quality points depicted on a standard worksheet. The next form is a time observation sheet. This form is not actually part of the documentation of standard work. More accurately, it is a data collection tool used to develop standard work. It's probably no surprise that I'm going to stress filling out the header information in this form also. So to use this form, the first thing you do is fill out the process steps. For consistency, these steps should match the ones on your standard worksheet and on your standard work combination sheet. Once you've got all your process steps identified and marked, it's time to start timing. This form is conveniently set up to help you keep up with the pace of production while you're making your observations. Each data box is split into two parts. On the top, you indicate the running time. And you'll go back later and do the math to come up with the individual task time. You'll have to record several observations to get an accurate time. The general rule of thumb is more is better. Of course, you may be limited by reality. If you have an exceptionally long process, you may not be able to take 10 cycle times. But for short cycles, try to take as many as you can. Here's one tip that will help make your time observation go more smoothly.
Thanks for watching this extended free version of our Lean Training System module video. If you want to watch the whole video, check it out at Velaction Videos. If you want to make sure you don't miss the next LTS video that we post, please be sure to subscribe down below. We also always appreciate likes as it helps us get viewed more and makes us keep adding additional content. Thanks for watching, and best wishes on your continuous improvement journey.